Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which transforms a BST to a greater sum tree. First, let us take an example. The idea is to traverse BST in reverse in order. Reverse in order traversal of a BST gives us keys in decreasing order. Before visiting a node, we visit all greater nodes of that node. While traversing, we keep track of sum of keys, which is the sum of all the keys greater than the key of current node. Now, let us see the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node, which is 11, and 0 to sum to transform tree util function. As root is not right subtree, so we pass the right child of 11, which is 29. Again, as root is not null, we further pass the right child of 29, which is 40. As root is not null, we pass the right child of 40, which is null. So, root will now point to null. As root points to null, we return to the previous call. Next, we update sum to sum plus roots data and roots data to sum minus roots data. So, sum will be equal to 40 and 40 to 40 minus 40, that is equal to 0. Then we pass the left child of 40, which is now 0. So, root will again point to null. As root is pointing to null, we return to the previous call. Execution for node 0 is over. Execution for root equal to 29 is resumed, and we update sum to sum plus 29. So, sum will be equal to 69. We store the old sum in current node. So, 29 will be replaced by 69 minus 29, that is equal to 40. Next, we pass the left child of 40, which is null. So, root will point to null. As root points to null, we return to the previous call and finish execution for node 40. Execution for root equal to 11 is resumed, and now we update sum to sum plus 11. So, sum will be equal to 80. Also, we update root to sum minus root. So, 11 will be replaced by 69. Now, we recur for the left subtree. So, we pass the left child of 69, which is 2. As root is not null, we pass the right child of 2, which is 7. Again, as root is not null, we further pass the right child of 7, which is null. Now, as root points to null, we return to the previous call. We update sum to sum plus 7 and roots data to sum minus 7. So, sum will be 87 and 7 will be replaced by 80. Next, we pass the left child of 7, which is null. So, root points to null. As root points to null, we return to the previous call and finish execution for node 80. Execution for node 2 is resumed, and now we update sum to sum plus 2. So, sum will be 89. We update 2 to 89 minus 2, that is equal to 87. Now, we pass the left child of 87, which is 1. So, root points to 1. As root is not null, we pass the right child of 1, which is null. As root is null, we return to the previous call. We update sum to sum plus 1. So, sum will be 90. Next, we update root to sum minus root. So, 1 will be updated to 89. Now, we pass the right child of 89, which is null. As root is null, we return to the previous call. Execution for all the nodes is over, and we have the final greatest sum tree. Now let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here n are the number of nodes in the binary search tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.